Hello. So in this video, we're going to talk about using higher order functions in JavaScript in order to be able to do functional programming within the JavaScript language. All right. So first place to recall is that we have functions in JavaScript. They again look very similar to functions in R, in Python or Java or R. Where again, we define a function by using our keyword function. We give it a name, parameter list, or can return some values. We call that function. We log out what it does. And we take the result, assign it to a variable, and log out what it does. That's our standard function. Those functions work just like every function you've ever worked with. That should work out just fine. So that's where we're starting, right? That's our basic function idea. But in this recording, we're going to make it get a little bit weird. So in JavaScript, functions are also values. So we don't distinguish between a variable and a function. They're actually all the same thing. A function and a variable are the same thing, which blows your mind a little bit, particularly for coming from Java, where there's very much distinction between sort of variables that are your nouns and functions that are your verbs. In JavaScript, functions are also nouns. They're also things that we deal with. So what's this look like? The idea is that a function is a value. It's a data type. Just like a number is a data type, or a string is a data type, or an array is a data type, a function is a data type. It's a type of information. It's a kind of value. So what this means ends up meaning is that anywhere you can use an array, like in code, as a variable, as an argument, as anything you want, you can use a function there instead. A function is just like a special data structure in many ways, the same way an array is a special data structure. So the primary version of this is that you can take a function and you can actually assign it to a variable, the same way you could assign an array to a variable. So again, think of the way that arrays work, is that I can declare an array by making an array literal, assigning that to a variable, my array. If I use that type of operator and I said what type of thing is my array, it'll log out object, because array is technically sort of a subset of object, but it refers it to a thing. And then I can take that my array and I can assign it to some other variable, right? I can put a different name tag on that value. So that value is now referred to by other in my array. Because other now refers to this data set, this data structure, I can use array's special power, like superpower, of putting brackets after it and a number inside those brackets in order to access a particular element of that array. So that's basic array work. And again, we can assign this array to that array data structure, that data type, that value to some other variable. We can do the same thing with functions. So a function, we can find a function like say hello, and this is a normal function that just console logs something out, basically the same thing we had in the previous slide. If we use type of, and I say what type of thing is say hello, because remember we called this function say hello. So if I say what type of thing is say hello, JavaScript will actually tell me, oh, say hello, that's a function. That's the data type it is. It's not a number or a string or an array. It's a function. So the idea is the say hello thing, I can refer to it by name. And that when I refer to it by name, that is a function. That's what I'm actually getting. So the idea here is that because it's a thing and I'm referred to by name, I can, of course, take that thing and assign it to some other variable called other. And now because this thing other refers to this function, I can use that function's superpower and special ability to put parentheses after it with an argument in the middle in order to call and execute that function. So similar to how I could say take an array assigned to some other and then use its special ability syntax, I can say take a function assigned to other and use its special syntax. So I can take functions and assign them to different variables in order to give them different names. So the way to think about this, like if you really sort of sit back and think for a second, often we think of functions as like instructions. They're recipes, right? The function says, here's a series of steps, a series of lines of code you want to execute and you want to call. In JavaScript, we don't just think of function as like the sequence of steps. We can also think of it as like the recipe itself. It's not just the instructions on a page in your cookbook. It's the actual page of the cookbook, like that physical page from the cookbook. And we can pick up that page and do other things with it. I can take that page and put a different label on it, right? That page is currently labeled, say hello. I can put an other label on that same page. So I can talk about both the function is both considering it as the set of instructions I'm going to follow, and then the result that's going to come out of following that, like what cake gets made at the end when I follow these instructions. But I can also think about it as the recipe, the piece of paper itself that contains those instructions. And so in JavaScript, we're actually going to think about functions in both ways, both as a series of instructions, but also then as a object, a value that represents a series of instructions. Okay, so this is how we sort of end up using functions. And there's some syntax that's going to go along with us being able to take functions and assign them to variables. So one of the things to note is that we can take functions and actually write them out as literal values, what we also will call anonymous values. Anonymous value is not a technical term. That's a term that I've used a lot. You'll see it in a lot of the stuff that I talk about. An anonymous value is basically just a value that hasn't been assigned a name. It's anonymous. It has not been given. We haven't labeled it yet. So for example, I can take a literal value, right? Literal is a technical term, and I can assign it to a variable, array. I pass it in. That's now a named variable, right? This value is not anonymous. It has a name. It's called array. I can also, of course, pass in the literal directly. This is what we refer to as an anonymous value because it's a value, but it doesn't have a name. Right? I never have a way of referring to it. I just use it directly. I pass it in directly. So that's kind of our anonymous value, which we write as just being like the literal representation of the variable, of the value. We do this with numbers and with strings and with functions, with strings and numbers and strings and arrays and all kinds of things all the time, right? This is a really common thing, right? Our code, right, was console.log hello world, right? We didn't assign hello world to a variable. That's just a value we just passed in immediately anonymously. So we can do the same thing with functions. Functions have literal values we can write. So we've learned to write a function declaration, which is what this is called. It's called a function declaration, where we use the keyword function, we give it the function name, and we put the arguments, etc. This is what you can think of as a named function. It's a function as a name. It's called a function declaration. It's also possible for us to write a function literal or an anonymous function, a function that does not have a name. And the way that we do that is by writing basically the exact same code, but without the function name. We just don't give it a name. We just leave that blank. So I can literally just take this function and I could have in my code a function definition, right? Function, person, thing. That's a function literal. This is defining a value. This is technically invalid syntax, right? That's why you're seeing the red underlines here, right? Is this actually a problem? It's the same way it's a problem as I can't just have a line of code that was hello world, right? I can't just have a string that's hello, right? This is not a valid line of code because I'm not doing anything with that identifier, with that string, right? I'm not assigning it to a variable. I'm not printing it. I'm not doing anything I want. Same thing here. I can't just have this literal like sitting out by itself. I have to do something with it. Just like if I had a string here, if I want to do something with that string, I would have to assign it to a variable, right? I could say, my string, right? So what I do, the way I did that is I took my literal, my hello, I put an equal sign in front of it, and then I put a constant variable name in front of it in order to give it a name. That's how we assigned this thing to this string. We can do the same thing with functions, right? I can take my function literal and I can assign it to a variable using the exact same structure, the exact same syntax we use to assign this random string to a variable. So I can say, here's my function, right? I can put an equal symbol in front of it and then give it a variable name, const my function. And now I have a function, a literal that's been assigned to a variable called my function. Just like this variable was assigned to a string, this variable, just like this value was assigned to the string to this variable, this value, this function has been assigned to this variable, my function. And of course, because my function is a function, I'm allowed to use a special power to call it, say world. And if I do that work, actually hello function, we'll call it that, so it sounds different. And then again, it logs out hello function. It calls that function, even though I gave it a name sort of at the separate stage. So this is called using a function literal syntax. So this is taking a function literal and assigning it to a variable. This syntax, right, where I take a literal and assign it to a name, and this syntax, where I declare the function with a name in the first place, are practically identical. They work the same way. They achieve the same effect. They both create a function called say hello that when I call it will console log some stuff. There are some slight distinctions about like when you define them this way in terms of like how they how like sort of what scoping that they then land in, which is not super relevant for us. Basically, keep it the line here is that there are two different ways we can actually declare functions. We can declare them using function declarations, this structure, or we can declare them using function literals. This is a good thing to know, mostly because I want to emphasize that function literals are a thing that can exist. We will occasionally define functions this way using literals. That's like a valid reason to do that. However, the majority of functions that we write, particularly top-level functions, right? Functions you'd write the same way you'd be writing things in Python or Java, we're going to want to name using function declarations. Like that should be your default syntax. But this is also a syntax of which I really enjoy, does in fact indicate that this thing is a value that we're assigning to a variable. All right. So that's a thing that we can do, right? I can make hello world and I make a function and assign it to a variable function called variable called say hello. All right. So functions are values. We can assign them to things. That means we can also assign them to properties in other objects. So for example, if I had an object and an array, I could take that array and assign it to the array property of an object, right? By using object.array is equal to my array. And of course, because this object.array is an array, it's a special type, I can put square brackets after it in order to access its special power, get the A out. And of course, I could have assigned an anonymous value, an array literal, directly to an object property, right? I could go directly to object.otherArray and assign that my variable, assign that my array. The same thing can happen with functions. I can have an object and I can have a function, say hello, they're the same function. I can assign the say hello function to the say hi property of an object. Same way I assigned my array to array, I assign say hello to say hi. Works exactly the same way, right? The function is just a value that I can assign to something else. And of course, because say hi is a function, I can use its superpower, put its parentheses after it, call it, execute that function, which will then print out hello all, just like we expect. And if we want to, just like I can assign an array literal to a property of an object, I can assign a function literal to a property of an object. So I can say, take my object's other function, and assign this function that logs out hello world. This is how we make non-static functions in JavaScript. Or if you want to make a function that belongs to an object, so you want to call like dog.bark, this is how you would give a bark function to a dog object if you had such a thing. We won't do that a lot in this class because we don't do that a lot, that kind of thing a lot in web programming, but that is kind of the structure that you might end up using. Okay, so functions are values. You can assign them to variables, right? We can do anything we would take any other literal, any other value. We can do functions in the same way. This is where it gets tricky. Because functions are values, they can be passed as arguments to other functions, which makes things get really weirdly meta. Okay, so again, let's go through this slowly, how this works. I can have an array. My array has ABC inside of it. I could define a function that takes in an array and console logs the 1th element. It's a stupid function. It's like totally pointless. Why does this function exist? I'm trying to make a really simple example of a function that fits on my half a slide here. So ignore how pointless this is and just like, let's keep in mind like this is what it does. It takes an array and it console logs the 1st element of the array. Sure, the 1 is hard coded in. It always does the 1th element. That's it. We're done. I can, of course, pass in do with 1, pass in the array, which would then log out the 1st element B, right? That array. I could pass in a literal object to say print out, and then of course, then when I say get the 1th element, it would log out the 2. If we want to sort of run this directly, right? We can make this more and more complex. Let's see. I'm going to rename this a little bit. We're going to call this. How about we'll call this log nth element. A little bit better name. And so we can say, let's log out the array and the nth element. So take in some index of what we want to log in. We'll console.log that array's nth element, right? Go to the array, get the nth element, log that in. So then I can say log my array out of my array, log the 2nd element. Out of this array, I could say log the 5th element, for example. When I run this code, it logs the 2nd element, the C, and then it logs the 5th element of my anonymous array, which of course is undefined. So what I've done here is I've made a function that takes an array and a number and then does something with that array and that. Cool. Basic things, simple. I mean, it's kind of a weird behavior to do, but it's the kind of thing that we've done. The kind of code you should be familiar with, the kind of code we've written before. Okay. The same thing can happen with functions. I can define a function, say hello. There's my say hello function. Make sure I'm going to get rid of the other stuff. so that we don't have any interruptions. Every time I say hello function, I can define another function, do with world, that takes as an argument, not an array, not a string, not a number, but a function. So it says, don't give me a number, give me a page from a cookbook, give me a recipe for me to work with. So the do with world function will take in that function. And then what it does, instead of accessing the 1th element and logging that out, it's going to call whatever function you give it. So whatever recipe we hand it, it's going to follow that recipe, specifying world as the sort of placeholder ingredient that it needs. So you can think of this almost as like, this is give me a recipe and I will follow it. I am the cook function. And the cook function, we give a recipe, which is a series of instructions. And the cook follows a series of instructions and builds them with world or with love. I don't know, something like that. So that's what we can then do. We can take my do with world function and, let's make it fun. We can do it with love. Right? We're going to do this with love. So we have our function say hello. We can do it with love. So then I can then call that function. I can say, hey, cook, do your thing with love. And that thing I want you to do is say hello. The say hello function logs out hello, the thing, and the cook does everything he does with love. So the cook will, of course, say hello, love. That's what he does. We could give other functions as well, right? I could have a function that was say goodbye. Oh my gosh. Console.log goodbye, comma, whatever that name is, right? This again is just a sample. This is just gotta do concatenation, sorry. This is again just a generic basic function. So our cook can here do something with love. He could say hello with love. That's what he does. He could say goodbye with love, and it works the same way. He says goodbye, love. So the idea here is that we have our function, our cook, who we don't hand him the word to say, right? He knows what word he's going to say. He's always going to say love. That's like his thing. That's what he does. He's always going to say love. We're going to give him the recipe, the set of instructions for him to work with. He will take those instructions and follow them, but anytime there's an argument, he's going to pass in, he's going to call those functions in his way, passing in sort of love as the argument. Similarly, if this guy was do with world, actually here, I'll leave the same name, but if he did love instead, world instead of do with love, then he would then say hello world, say goodbye with world, and we get the exact same kind of effect. All right. So the trick here is we have functions that we can pass as arguments to other functions. We can take the recipe, the instructions for how to follow the function, and give that as the instructions to some other function. Say, hey, you, other function, here's your recipe, do this thing. And that other function can call our recipe, can follow it, can bake that cake to get the result that it needs. Okay, cool. This becomes the really tricky part as you're sort of getting used to and figuring this out. Because we now have these two different views of a function, right? Both as like a set of instructions that we followed and also the recipe that contains a set of instructions, we have to distinguish between when we are calling a function, we're actually saying, let's follow those instructions, let's do what's on the recipe, and when we're talking about passing around the function, we're actually working with the recipe itself. So there's a distinction between calling a function and passing in a function. When we pass in a function as an argument, we don't put parentheses after it. When you put parentheses after the function name, when you say like say hello with parentheses after it, when you say a function with parentheses, when you say do with love with parentheses, when you put console.log with parentheses, putting that parentheses after the name calls the function. It executes it. It says, follow this recipe, mix all your stuff, put it in the oven, bake your cake. It says do that set of work. When we want to pass around the function, we don't actually want to call it yet. If I'm trying to give someone a recipe, I don't actually want to start following the recipe and baking the cake. I don't want to go into the kitchen and start doing that. I just want to hand the recipe to somebody else and then let them go do the cooking, go do the actual work. So the idea is that when we pass in a function, we want to pass it in by name without calling it. I don't put parentheses after it. The behavior you'll end up seeing then is that, for example, if I have my function, and this is going to be my say hello, which I'm going to rename to be get hello because it returns a value just to be distinguished between printing and getting. So if I have my get hello function, if I console, oh my gosh, if I console.log get hello, right? Notice I'm not putting parentheses after get hello. I'm saying take that recipe and let's log out the recipe. What Chrome actually does is it'll actually log out the recipe. It literally will say, here's your instructions. It is a function. It puts a big F indicating that it's a function. And then because it's within scope and because of how everything's got access at the moment, it'll actually be able to log out. Oop, don't do that. Don't click on that button. Stay on your console. It'll actually be able to log out all the source code for that function. You can actually see what does this thing look like. Now, instead, if I console log get hello with parentheses after it, right? If I put those parentheses after get hello, that calls the function, it executes it, actually says, oh man, we better go follow these instructions and bake that cake. So we start cooking, we start baking the cake, right? What do I do? Well, I immediately return a hello cake. That's the cake that got baked. So that in this line of code here at line 31, JavaScript's going to take this function, it will evaluate it, it will follow that recipe and replace that, right? It replaces this thing with what it evaluates to. So effectively, it replaces it with hello, because that's what calling get hello produces, right? It makes this, the result is hello. Because of that, it'll console log hello. It's not logging out the function, the recipe, it's logging out the result of calling the recipe. The metaphor I will use, and you'll hear me talk about this a lot, is that distinction between, again, the recipe and the cake. This here, without parentheses, refers to the recipe. When I put parentheses after it, I'm not talking about the recipe anymore. I'm now talking about the result of following the recipe. What I got at the end, I'm talking about the cake. And there's a big distinction here, right, between a cook. For a cook, if I say, here's a recipe, follow this. And if I say, here is a cake, follow this. If I give a cook a recipe, they'll say, oh, yes, I can follow the recipe. I can read the language, and that's all great. If I hand them a cake, they're going to look at the cake and say, how do I follow a cake? They don't know what to do with that, right? They don't have any idea how to follow cake. They can follow recipes. They cannot follow cakes. So we need to distinguish between, am I talking about the recipe, the function, or am I talking about the result of calling the function, the cake? Okay. Here's another example of how this works. So the other piece of language or terminology we're going to use here is that when we're passing a function into another function, that thing we're passing in, that recipe we're giving, we refer to as a callback function, because the idea is it's a function we're going to call back to later. Right? We're going to eventually say, okay, we're going to call that function at some other point in the future. We're going to go back to it and call it later. So they're referred to as a callback, a thing for us to do in the future at some other point. Okay. So here's a function. This function is called doTogether that takes in 2 recipes as arguments. That's okay. We've taken in multiple functions before, right? Multiple arguments into values before. Like we have functions that took in, like, you know, the standard print name takes in a first name and a last name. That's 2 strings. This function takes in 2 functions. That's the data type. It's like something that might take in 2 arrays or 2 objects. This is 2 functions. So it's going to take in the 2 functions. It's going to execute the first function. It will execute the second function, and then it'll console log at the same time. They're not actually happening at the same time. It does the first function, then the second function. They're not actually synchronous, or they're not concurrent. They're not happening at the same time, but we're going to log out at the same time to pretend that's what's going on. All right, so that's our function we're going to work with. We, of course, then also have a function pat head that pats your head, and a function rub belly that rubs your belly. So let's see what this works like. I'm going to comment out my get hello stuff for the moment. All right, so here's my doTogether. It takes in the first callback, second callback, executes the first thing. I'm going to leave the comment just so we have some room here. Executes the second thing at the same time. So if we call this function, we're going to say doTogether. I'm going to pat my head, rub my belly. I'm passing in the recipe that's labeled, that has the title at the top of it, pat head, and the recipe that is labeled rub belly. That's what we're passing in. So I pass in those 2 things to my cook. I say, hey, cook, first follow this instruction, rubbing your head, then follow this instruction of rubbing your belly. Go have fun. The cook does that, and what we get is pat your head, rub your belly at the same time. This was what we hoped would happen. Now, if we put parentheses after pat head, And I'm going to comment out the our do with love stuff in a moment so that it's easier to see. So we put parentheses after pat head. Now, what we are doing is we are not passing him a recipe that says instructions on how to pat your head. We're instead saying, go pat your head, and whatever the result of that is, do your results. When we do that, when we run this code, you'll notice that it says pat your head, but then it crashes and we get an error, right? Our code stops. It now says that we need to rub that first callback is not a function. Okay, what's going on here? So again, when I put parentheses after pat head, what that really means is I'm saying pass in the result of pat head. So it's almost like what I did is if I had a line of code here that was pat your head and assign that to a result, what I'm doing is I'm passing in that result. So I'm saying, here's the result I want you to do together, and here's the rub belly that I want you to do. So we're going to pass in the result. Now, the error here, of course, we're getting comes back here. So I call do together and I give him a result. So he gets this thing called he calls it first callback. That is my result. And then I get second callback, which is my rub belly. So what is result? Well, if we console log our result, we try to say, what is the result of patting my head, right? But I'm not going to do together anymore. I'm just going to say, like, I'm going to pat my head and log out the result. It pats my head, right? Because it calls pat head, that rubs that calls to logs, pat my head, and then it logs the result, which is undefined. My pat head function doesn't return anything. There is no return statement in pat head. Therefore, the value returned by pat head is undefined. It doesn't break like Java where it says, oh, you tried to return as a void function, but you can't assign it to a variable. JavaScript says, cool, it's a function that doesn't, you want to assign it to a variable? Awesome. Here's your result. You didn't actually say what to return, so the return value was not said, it was undefined. So what that means is that my result is undefined because pat head doesn't say what to do. So effectively, when I called do together, I was passing in undefined as the result, right? I'm going to say do together undefined, do this undefined thing, and also rub your belly. My do together takes in undefined as our first callback, which means effectively first callback is undefined. So it's trying to call undefined with parentheses after it. And that doesn't work because undefined isn't a function. We cannot call undefined. So it can't used to do that work. Hence the error that we get where it says first callback is not a function. It's not a function. It's undefined. Hence why, right, going all the way back to where we started from, like how we got here, we can't call pat head with parentheses after it because then we're not passing in the instructions on how to pat your head. We're passing in the result, the end state of patting your head, which is undefined. Okay. This is a pretty common kind of error that you can have, right? Where students were, particularly, not even students, anybody writing JavaScript code, that when you're trying to pass in a function, you accidentally put in the parentheses after that function name. You have to, it's hard because you've spent your entire programming career always putting parentheses after function names. That's how they're written. That's how you talk about them. There's like, you've never had to worry about having a function that didn't have parentheses after it. What you have to do now for JavaScript is you have to sort of untrain yourself. You have to sort of break that habit of always writing the function name with parentheses after it because sometimes you don't want those. Sometimes you only want to refer to the function itself. So that's a habit. It takes some effort to break that habit, but that's what we'll need to do. If you get that kind of error, right? If you forget, we all forget, it's normal. If you forget and you put those parentheses after it, you'll get this error up here. It says that first callback is not a function. It doesn't actually tell you that the problem is coming from line 50, where the actual error, like this is where I mistyped something. It says the problem is happening up here, that first callback is not defined. The way that I recommend debugging this is we can actually start saying, all right, if JavaScript says that first callback is not a function, then my first question is, well, if it's not a function, what is it? I could have sworn it was a function. Wonder what that is. So what we can do is we can, of course, log out first callback. And we can put a little label on it. And we can log out what is this first callback thing. Then when we run our code, it tells us that first callback is undefined. We're like, oh, okay, I must not have been passing a function in, I must have been passing in undefined. Why did that happen? And then you can go back to see where you passed in a value and you realize that, oh my gosh, I can't believe I forgot I put the parentheses there. Take the parentheses away, everything still works. Now it says, now when of course it logs out that first callback, it's a function and everything's working the way I want. Okay. Note that it was still past, like when I had the parentheses here, note that it was still patting my head because this was still working fine, right? It still patted my head. Here, let's get rid of this one. Because we did call the pat head function, it's only broke when we tried to do something. In the other situation, if I, for example, put rub belly parentheses on that, what you'll see is it'll look like rub your belly, then pat your head, and then errors. Which almost actually, like it almost looks like it's working, right? Because what's happening here is that when we need to call this function, it's that JavaScript says, oh, I need to evaluate rub belly because that's calling that function. I need to do that first. I need to evaluate before I can pass something in. Same way that if you use something like math.round or use some other function you want to use, the length function, you'd have to pass it. You have to call that function, evaluate it, and then pass in the results. So it rubs our belly to try to figure out what the result of that is. Then it's undefined. So then it passes in pat head and undefined. Do together does the pat head thing. That works great. And that, right, note that that's happening after rub our belly. And then it tries to do the undefined thing. That breaks. So we never get to the at the same time part. Whew. Okay. I know that's a lot of stuff kind of moving around and shifting. The important thing to take away here, right? The really important bit here is that when we're passing in a function, we do not put parentheses after it, right? There's a distinction between the recipe, the piece of paper that has the instructions on it, and the result of following that recipe, the cake, the thing that we actually cooked. And those are different things. We have to keep those concepts separate. Whether we are calling a function and saying, JavaScript, please follow these instructions and do them, or whether we are actually just passing in the instructions to be used later. We're passing in that recipe as we go. Okay. So that's the basic idea with callback functions, with passing in higher order functions. We are going to use this so much. We're going to use this all over the place. It is huge in JavaScript. It's one of the most, and particularly in web development, it's one of the most common things we end up using. The way that we're most often going to use it is occasionally we'll write functions that take in other functions. You're going to do some of this for practice to like get used to the concept, but this actually isn't super common. We're not going to do a lot of writing functions that take in other functions, right? We're never going to define arguments for functions that are themselves callbacks. But what we will often do is we're going to use built-in functions that are provided by JavaScript, the JavaScript and the web libraries that expect functions as arguments. So the same way that if you call like math.square root, you have to pass it in a number, right? It expects a number. You can't pass it in a string. It will get mad. That will not work, right? This function expects a number. There are functions that are built into JavaScript that expect other functions, that expect recipes as their arguments. As an example, just to show you that such a thing exists, arrays, we love arrays, we're going to use arrays, right? Arrays support a method called sort, which will sort the array, as expected. The sorting function takes as an argument a recipe, a set of instructions for how, what are you doing? Well, takes as a set of instructions how to do that sorting. It takes in a sorting function, a comparator function. If in Java you did compare by or the sort of the compare to function interface, same idea going on here. Python works the same kind of way. So for example, I could define a function that says how to sort two people, a person A and a person B. It tells me if you give me two people, I can tell you who comes first. So I can basically do that by comparing their height, and then I return a number. A negative number says that person A is first, a positive number says person B comes first, and 0 says they're the same. Once I have to say that's how you can compare two people, I can then hand that function to the sorter, and I can say, hey, sort them by using this comparison. As you're like comparing people to figure out who goes first, here is the rubric you can use. Here is the instructions you can follow on how to evaluate those people. Basically, it's like a rubric for like an essay or a page or something like that. So that will let us then be able to sort our people by using that function. Note what I'm doing here is I'm passing in a function, not the result of calling a function. I'm passing the function itself. Cool. I'll show you this works real fast. Let's demonstrate that. So there's my people array. I'm going to sort it. If I console.log my people array. Oop, oh, gotta get rid of the broken padding head stuff. Right, here's my people array, and note that they are now sorted, right? The shortest people, the lowest height comes first, and if it cleans my way up, they're no longer in alphabetical order. They've been sorted. If I put parentheses after sort by height function, I get an error because it's basically trying to call this function. It's expecting 2 people, and there's no people for me to pass in. I don't have the people to pass into it yet. Like, even though they're coming from people array, I don't know which people to pass in because I'm not doing that work. I'm not actually comparing the people. I'm just saying that if you had 2 people, here's how you could compare them, and I'm letting the JavaScript sort function do that actual comparing work. So again, the important parts here is that as we're passing functions into these built-in libraries, these built-in sort of other functions, other methods, we're often not passing in the arguments. They are going to be called, and the right arguments will get passed in. We just sort of have to structure our sorting function so that it works as expected. That's part about understanding the library for these other functions. And we will go through what some of these other functions are that expect these other methods that expect functions as arguments, that take in callbacks. And we'll go through the syntax and the expectations and what kind of function, what format that function has to take in order for them to work sort of as we introduce them. Similar to how like some strings might say that string has to be this many letters long, that number has to be this big. We might say that function has to have this many arguments. Make that all work. Cool. And we'll go through some examples of that in future videos and future explanations.